we're going to add some topics to it. All right, so on page 68 today, we're talking about the Pythagorean theorem. The Pythagorean theorem. That is on page 68.
Sounds from ancient Greek.
Kinda. So page 68, the Pythagorean theorem. Once you've got that written down, turn to page 57 for our objectives. So everybody should have a notebook out or a piece of paper out. And we're on page 57 for our objectives. So, page 57, once again, our topic for this week is the Pythagorean theorem. And our objectives for today are to use Pythagorean theorem to prove right triangle. So we're using, bless you, the Pythagorean theorem to prove the right triangle, and we're going to solve using Pythagorean theorem. So once again, we're talking about the Pythagorean theorem this week. We're going to use the Pythagorean theorem to prove whether a triangle is right or not, and we're going to solve using the Pythagorean theorem. So once we've got that written down, flip on over to page 68, please. So page 68, Pythagorean theorem. So once again, page 68. Pythagorean theorem. The Pythagorean theorem deals with triangles, specifically right triangles. So let's say we have this triangle with a right angle right there. Pythagorean theorem works for right triangles, and this little square denotes that that angle is right 90 degrees. For simplicity's sake, and for you guys' help, we're going to give you rules to, to label each side. So, we're going to have three different sides. Side A is going to be the shortest side. What do you say, Avery? Yes, B is going to be the medium side. So A is the shortest, B is the medium side, and C will be the longest side. So looking at this triangle, where is the longest side? Is it 1, 2, or 3? 1. So that's going to be C, our longest side. We'll give that a name here after the next couple of minutes. So for right now, C is the longest side. A is the shortest side. So the shortest side is to the left, and the medium side, B, is here. If the shortest side's on the bottom, it's A. For simplicity's sake, A and B are interchangeable, but for your guys' help, just label the shortest side A, the medium side B, and the longest side C. Sound good? So, when we're talking about the triangle, we have two different types of terms that we use. We have legs for the two shortest sides. So for the short and the medium side, they're called legs. So A and B are legs of the triangle. So A and B are legs of the triangle. And C is what we call the hypotenuse. So HY, POT, EN, USE. The hypotenuse. The hypotenuse is the longest side. It is always the longest side. And it is across from the right angle. So it is the longest side across from the right angle, and C is what we call the hypotenuse. So I'm going to go ahead and draw you a picture here, and then I'm going to ask you a question. So the shortest side A, medium side B, longest side C, the hypotenuse. If I were to ask you which one of these is going to be bigger, the legs, so the area of the legs, or the area of the hypotenuse square. These are both squares. These are all three squares. What do you guys think? Would you rather have an area of A and B together, or C? So the area of a square C times C, or the area of B times B plus A times A? If you want the C times C square, raise your hand. If you want the A plus B square, so we have what, 6 people in this class? Participation, please. So if you want the C, raise your hand. 3, 6, 9, 12. Alright, if you want the A plus B. There's like 8 of you guys that still aren't raising your hand. Alright, well, we're going to show you how this works. So, this right here is one of the proofs of the Pythagorean theorem. So the Pythagorean theorem states that A squared plus B squared equals C squared. So in a right triangle, the area here plus the area here is going to equal the area here. So A squared plus B squared is going to equal the area of C squared. So to prove this, or to show you an example, let's say that we had sides where A equals 3, B equals 4, and C equals 5. So we're going to plug this in to the Pythagorean theorem. We're going to substitute our values. And A was equal to 3. So we have 3 squared, substitute 4 for B, plus 4 squared, substitute 5 for C equals 5 squared. 3 squared is 9. 4 squared is 5 squared is 9 plus 16 is 25 equals 25. So the areas in a right triangle using the Pythagorean theorem are going to be the same. So a squared plus b squared equals c squared. Are we following so far? Any questions? Okay, good. So when we're looking at this, the first 6 problems on our homework are going to ask you, do these side lengths give you a right triangle or not? So a right triangle is when a squared plus b squared does equal c squared. That denotes a right triangle. 12. So if a squared plus b squared equals c squared, that's a right triangle. If a squared plus b squared does not equal c squared, then that is not a right triangle. I believe on the homework all it asks is yes or no, but you have to show your work. I'm going to write right triangle or not right triangle just to enforce that into our brains. But on the homework I believe it just says yes or no. Asks for it. So, once again, a squared plus b squared, if it does equal c squared, it's a right triangle. A squared plus b squared does not equal c squared, then that is not a right triangle. So let's take a look at a couple examples to see what this looks like. Let's say we had, for example, our values are 6, 8, and 9. Those are the 3 sides of our triangle. 6, 8, and 9. How are we going to set up our equation using the Pythagorean theorem to see if this is a right triangle or not? Zach?
So it's going to be 6 squared plus 8 squared equals 9 squared.
That's how we're going to set it up. Why'd you choose 6 squared first? Because it's the smallest, and the smallest, the shortest side goes to A. So 6 squared plus 8 squared, and we're going to see if that equals 9 squared. So we're questioning to see if 6 squared plus 8 squared is going to equal 9 squared. Noah.
Do we have to write out that problem, or just write out what each says in square form?
Are you saying, do you have to write 6 squared, or can you just write 36? You're going to have to write 6 squared because some of them it's going to be like 11.2, and we don't know 11.2 squared off the top of our head. So, what's 6 squared? 36. What's 8 squared? 64. What's 9 squared?
81.
What's 36 plus 64? Does 100 equal 81?
No.
So what does that mean?
No.
Not a right triangle. It's very possibly a triangle.
No, it's not a right triangle. It's like 1 degree off.
It's a wrong triangle. It's a left triangle. Not a right.
So, the side lengths, no face forward please, of 6, 8, and 9 do not give us a right triangle using the Pythagorean theorem. So let's say we had these values.
6, 8, 9, 6, 7.
Let's 6, 8, and 10 would. So let's say we had 13, 5, and 12. Let's say those were our 3 side lengths for our triangle. And we need to set up our Pythagorean theorem and substitute our values. Avery.
5 would be A, 12 would be B, and 13 would be C.
So 5 is A, so 5 squared. You said B is 12, good. So 12 squared equals 13 squared. So 5 squared is
25.
25. 12 squared is
144.
144. And 13 squared is 169. So 25 plus 144 equals 169. And that checks. Zach, face forward, please. So, is this a right triangle?
Yes.
Yes. So, right triangle. So those are the problems you'll see for the first 6 problems on your homework. Those are the types you'll see. You might just see like some of these problems. So make sure you're paying attention. So the other types of problems we're going to see is we're going to solve for C. They're going to give us a value for A and a value for B, but we're not going to know C, and they're going to ask us to go find it.
So they're all going to be rectangles.
So you just need to add them, right?
The, like 7 through 12. Right?
7 through 12 will all be right triangles, yes. So let's say we have, they gave us this triangle right here. They gave us this right triangle. They gave us that this side length is 4, this side length is 12, and this side length is C. Let's think about how we're going to set this up.
What number is C?
We're trying to find C.
No, C is my favorite number.
That's awesome.
Well, I thought that was a 6.
C is my favorite
It'd be-
number of the rainbow.
All right, so it'd be impossible if the hypotenuse was 6.
When you said it.
All right, let's focus back up. So, how are we going to set up using the Pythagorean theorem to solve for C? Good. We take 4 squared because A is the shortest, or 4 is the shortest side, so it's A. Then we have our second side, which is B, the medium length side, which is 12. Square it. And that is equal to what? C squared.
80 equals 80.
So, 4 squared is
8.
16.
16. What's 12 squared?
144.
144, and that still equals C squared. So 16 plus 144 is?
160.
And that equals C squared. So,
Some magic right there.
C squared equals 160. What is the inverse of the square of something? It's the square root of something. Good, Jonathan. So we take the square root of both sides. So the square root of C squared is just simply C. And now we have a problem that looks a lot like something from before spring break.
We weren't ready.
So we have the square root of 160. And now we need to factor tree 160.
10 and 6.
10 and 6?
4, 10.
Oh, 16.
10 and 16?
Yes.
We can go with 10 and 16. That works. 16 perfect. That gives us 4 and 4. We circle our pairs. Can we do anything with the 10? No. So what's our answer for C? What does C equal? 4 square root of 10. So that's how we solve for C. We take our value for A, square it. We take our value for B, square it. Add A squared plus B squared. That equals C squared. Take the square root of both sides. And solve. Zach. That problem, no. There'll be problems like there are 6 problems that ask you to solve for C. If they end up like a radical, I think 4 of them do, at least. So your homework is posted on Google Classroom. I will put it on the board.